Question 4.1.1, we have to evaluate the integral of e to the power the square root of sine x over sec x multiplied by the square root of sine x dx. Before we integrate, let's rearrange our integral. We know that 1 over cos x is equals to sec x, and that 1 over sec x is equals to cos x. So in the place of 1 over sec x, let's substitute cos x. And we'll be left with the square root of sine x as our denominator, and from here we can let u equal sine x du over dx. When we differentiate sine x, we get cos x. We multiply both sides by dx, and du equals cos x dx. In the place of sine x, we substitute u, and in the place of cos x dx, we substitute du. And from here we use the u substitution method again, but let's use another letter so that we don't get confused. We let t equal the square root of u. We rewrite our u as a u to the power 1 over 2. So when we differentiate t with respect to u, we have 1 over 2 multiplied by u to the power 1 over 2. We minus the half. 1 over 2 multiplied by negative 1, we get negative 1 over 2. And this will be equals to 1 over 2 multiplied by 1 over u to the power 1 over 2. We know that if we had a to the power negative 1 is just the same, or negative 2 is just the same as 1 over a squared. And this can be rewritten as 1 over 2 multiplied by 1 over the square root of u. So dt over du is equals to 1 over 2 multiplied by 1 over the square root of u. So we have du. So let's multiply both sides by du. We get 1 over the square root of u multiplied by du. And we can see that we have du over the square root of u without the 1 over 2. So let's multiply both sides by 2. That 2 will cancel out that 2. So we have 2 dt is equals to 1 over the square root of u du. In the place of du over the square root of u, we'll substitute 2 dt. And in the place of the square root of u, we substitute t. In the place of du over the square root of u, we substitute 2 dt. We can choose to take the 2 out of the integral. We have to integrate e to the power t. When we integrate e to the power t, we get e to the power t plus c. Our integral is not in the form of t, it's in the form of x. But before we can substitute anything with x, let's substitute back the square root of u in the place of t. And finally we can substitute we can substitute the sin x in the place of u, and this becomes our final answer. In the memorandum, they actually let, so let's substitute the cos x for 1 over sec x. In the memorandum, they let u equal the square root of sin x. So du over dx, we can derive this as sin x 1 over 2. When we differentiate u with respect to x, differentiating that, and the chain rule says that we must also differentiate the inner function sin x. When we differentiate sin x, we get cos x we choose to write sin x to the power 1 over 2 as the square root of sin x cos x, and we multiply both sides by dx. That dx will cancel that dx, and du will be equals to 1 over 2 multiplied by cos x over the square root of sin x dx. We have cos x dx over the square root of sin x without the 1 over 2, so let's multiply both sides by 2. So we have 2 du is equals to that 2 cancels that 2. 2 du will be equals to cos x over the square root of sin x dx. So in the place of cos x dx over the square root of sin x, we will substitute 2 du, and in the place of the square root of sin x, we substitute u. We choose to take the 2. We choose to take the 2 out of the integral. When we integrate e to the power u, we get e to the power u plus c. Our integral being in the form of x, we substitute back the square root of x in the place of the square root of sin x in the place of u. Question 4.1.2, we have to determine the integral of sin 3x multiplied by sin of negative 2x dx. On our formula sheet, we have the following formula: sin a multiplied by sin b is equals to 1 over 2 cos of a minus b minus cos of a plus b. In this case, our a is 3x and our b is negative 2x. So our integral over 2 cos of a minus b, so we have 3x minus 2x, so that minus will be positive, 2x minus cos of a plus b, our a is 3x and our b is negative 2x, so that negative plus that positive will be negative 2x dx. Cos of 3x plus 2x is equals to 5x minus Cos of 3x minus 2x is cos x dx. So when we integrate the cos 5x, we get sin 5x, and because of the chain rule, we have to divide by that 5 minus integrating cos x, we get sin x plus c, and we have that as our final answer. 4.1.3, we have to determine the integral of cos squared x multiplied by sin cube x dx, and between the cos and the sin, the one which has an odd exponent, we have to break and convert, and you can see that the sin has an odd exponent 3, so we will break the sin and convert it. So we break the sin as sin squared x multiplied by sin x dx, and we know that sin squared x plus cos squared x is equals to 1 when we make sin squared the subject of the formula, sin squared x the subject of the formula, by taking the cos squared x to the right, it changes sign into negative cos squared x. So in the place of sin squared x, we will substitute 1 minus cos squared x. And we write that sin x. And from here, we have to let u equal cos x. When you differentiate u with respect to x, differentiating cos x, we get negative sin x. We multiply both sides by dx, and du equal negative sin x dx. We have sin x dx there without the negative, so let's get rid of that negative by multiplying both sides by negative 1. So negative du will be equals to sin x dx. So in the place of that sin x dx, we will substitute negative du. So our integral, so in the place of cos x, we substitute u, but that cos is squared, so we also square our u. In the place of that cos x, we substitute u, and also that cos is squared, so we also square the u. And in the place of that sin x dx, we substitute negative du. We can choose to take the negative out of the integral since it's a constant, and we distribute the u squared inside our parenthesis. U squared multiplied by 1 is equals to u squared. U squared multiplied by negative u squared is equals to negative u to the power 4 du. That negative, we took it here. From here, we integrate. Integrating u squared, we get u to the power 3 over 3. Integrating u to the power 4, we get u to the power 5 over 5 plus c. Our integral is not in the form of u, it's in the form of x. So let's take back the cos x in the place of u. But the u is cubed, so let's also cube the cos x. From here, let's distribute the negative inside the parenthesis. So we'll have negative cos cube x over 3. That negative multiplied by that negative will be positive cos to the power 5 x over 5 plus c, and this becomes our final answer. 4.1.4, we have to evaluate the integral of 3x cubed minus 2x squared plus x minus 5, all divided by x plus 2 dx. We have to use long division to determine this integral. 3x squared, 3x cubed divided by x is equal to 3x squared. 3x squared multiplied by 3x is equal to 3x cubed. 3x squared multiplied by 2 is equal to 6x squared. From here we minus 3x squared minus 3x squared is equal to 0. Negative 2x minus 6x squared is equal to negative 8x squared. We take down the positive x. Negative 8x squared divided by x is equal to negative 8x. Negative 8x multiplied by x is equal to negative 8x squared. Negative 8x multiplied by positive 2, we get negative 16x. From here, minus negative 8x squared minus 8x squared is equal to 0. X minus minus 16x is equal to 17x. We take down the negative 5. 17x divided by x is equal to 17. 17 multiplied by x is equals to 17x. 17 multiplied by 2 is equals to 34. 17x minus 17x is equals to 0. Negative 5x minus 34 is equals to negative 39, and we stop here because the negative 39 is not paired to an x, so we write that negative 39 there, and we divide it by what's in here. So what we have there is x plus 2, so we'll have the integral of 3x squared minus 8x plus 17 minus 39 over x plus 2 dx. If you are unsure with your steps, you can take any number and substitute it here, and take that very same number and substitute it there. You should be able to get the same number. If you don't get the same number, it means that you made a mistake with your steps. So when we integrate 3x squared, we get 3x cubed over 3. Integrating negative 8x, we get negative 8x squared over 2, and integrating the 17, we get 17x. Integrating negative 39 over x plus 2, we get negative 39 ln of x plus 2 plus c. We can polish this off. Negative 8 divided by 2 is equals to 4. And we have that as our final answer. 4.1.5, we have to determine the integral of x cubed multiplied by e to the power x squared divided by x squared plus 1 all squared dx, and we are given a hint that we must let u or f of x equal x squared multiplied by e to the power x squared. So let's break our integral. So we'll have x multiplied by x squared multiplied by e to the power x squared. So that x squared is fulfilled here, divided by x squared plus 1 squared dx, and that is just an advice for us to use integration by parts, where we'll have the integral of f of x g prime of x dx is equals to f of x multiplied by g of x minus integral multiplied by f prime of x g of x multiplied by f prime of x dx, or the other formula you can write u integral of u dv is equals to u multiplied by v minus the integral of v du. So we have to let f of x, or that u if you're using that formula, equal x squared multiplied by e to the power x squared. So we have f of x and g prime of x, and you're already told that the hint is that we let f of x equal x squared multiplied by e to the power x squared, and g prime of x will be left as, since this will be our f of x, so the remaining part will be our g prime of x. So our g prime of x will be equal to x over x squared plus 1 squared. We have to differentiate f of x so that we can get f prime of x, and we also have to integrate g prime of x so that we can get g of x. And to integrate that, so let's start by differentiating f prime of x. We use the product rule because we have two functions, x squared and e to the power x squared. So when we use the product rule, we differentiate this one and we let that one as it is, plus we differentiate this one, e to the power x squared, and the chain rule also says that we must differentiate the x squared, and when we differentiate the x squared we get 2x, and we have to let that one as it is. From here we can see that we have 2x here and e to the power x squared. Also we have 2x here and e to the power x squared, so we can take these as our common factors. So we have 1 plus x squared as the remainders after taking these two as our common factors. So now we have to integrate the g prime of x so that we can get g of x. So let's see, integrating that, we have to let u equal x squared plus 1 du. When we differentiate du with respect to x, differentiating the 2x, we get the x squared, we get 2x, multiplying both sides by dx, we get 2x dx. We can see that we have x dx without the 2, so let's divide both sides by 2. So our du over 2 will be equals to x dx, that will cancel. So we have x dx there, which we will substitute with that x dx, and the u will substitute with that x squared plus 1. In the place of x squared plus 1, we write u. We can choose to take the 1 over 2 out of the integral, and we'll be left with 1 over u squared multiplied by du. And we can also choose to write our integral as u to the power minus 2. Integrating u to the power negative 2, we get u to the power minus 1 divided by minus 1. This will be equals to negative 1 over 2 u to the power negative 1, which we can rewrite as negative 1 over 2 multiplied by 1 over u. And we already said that our u is x squared plus 1, and this will be our g of x. So this will be our g of x. So we are still integrating by parts. So from that formula, so we'll have the integral of x multiplied by x squared multiplied by e to the power x squared dx. We'll have this as equals to f of x multiplied by g of x. Our f of x is x squared multiplied by e to the power x squared, and our g of x we determine as negative. So let's write that negative 1 over 1 over 2 multiplied by 1 over x squared plus 1 minus the integral of g of x multiplied by f prime of x. Our g of x we determine as negative 1 over 2. So that negative multiplied by this negative will be positive 1 over 2 multiplied by 1 over x squared plus 1 multiplied by f prime of x. Our f prime of x, we simplified it and we took out the common factor and we said that it was equals to 2x multiplied by e to the power x squared multiplied by 1 plus x squared dx. That x squared plus 1 is just the same as that 1 plus x squared. That 2 will also cancel that 2, so we'll be left with the integral of x multiplied by e to the power x squared dx. And from here we have to use the use substitution method or integration by parts. But let's use the use substitution method where we let u equal that x squared. Du over dx will be equals to 2x. Du, we multiply both sides by dx, so we'll have du is equals to 2x dx, and we have x dx without the 2, so let's divide both sides by 2, so we'll have du over 2 is equals to x dx. So we still have that negative x squared multiplied by e to the power x squared over 2 multiplied by x squared plus 1 plus the integral of the x dx will be replaced by du over 2, and the x squared will be replaced by u multiplied by du over 2, and from here we will integrate e to the power u integrating e to the power u, we write that 1 over 2 out. So now we have to integrate e to the power u, and we get e to the power u. So in the place of that u, we will substitute x squared, and this will be our final answer. Question 4.2, the instruction was that we use partial fractions to determine the integral of 11 minus 3x over x squared plus 2x minus 3. Normally, we will get this simplified or factorized, but in this case, the x squared plus 2x minus 3 is not factorized, so let's factorize it. So the factors of x squared is x and x. The factors of 3 are 3 and 1. We take that sign, we put it here, and the sign that we put here multiplied by this side should give us that sign. So negative multiplied by this positive is equals to negative. So we have to test if this is correct, because we are using trial and error method to determine the factors. So 1 multiplied by x is equals to x. X multiplied by negative 3 is equals to negative 3x. And this will give us negative 2x. And we don't have negative 2x as our middle term, we have positive 2x. So this is incorrect. So let's reverse the factors of 3. Let's put the 3 here and the 1 there. So 3 multiplied by x is equals to 3x. X multiplied by negative 1 is equals to negative x. 3x minus x is equals to 2x. And we have positive 2x there as our middle term. So this is correct. So we can move on and we equate this as the integral of 11 minus 3x over x plus 3 multiplied by x minus 1 dx. 11 minus 3x over x plus 3 multiplied by x minus 1 is equals to a over x plus 3 plus b over x minus 1. We multiply both sides by x plus 3 and x minus 1. So we managed to multiply both sides by x plus 3 and x minus 1. That x plus 3 will cancel that x plus 3. That x minus 1 will cancel that x minus 1. So we'll be left with 11 minus 3x on the left side of the equation. And on this side of the equation, we have to distribute the x plus 3 multiplied by the x minus 1. We divide by x minus 1 this side because this x minus 1 cancels that x minus 1. This x plus 3 cancels that x plus 3. So we have 11 minus 3x is equals to a multiplied by x minus 1. And we are left with b multiplied by x plus 3. So we have two unknowns, a and b. So we substitute x as two numbers, any numbers, but the simplest numbers that we can substitute with is going to be 1, because when you put 1 here, this side will be 0, and that 0 multiplied by a will be 0. And we can also choose x as negative 3, because we can see that if we were to substitute negative 3 here as x, negative 3 plus 3 will be 0, and it will cancel out this b, and we'll be left with a. So let's substitute first. X is equals to 1. Negative 3 multiplied by that 1 will be negative 3. And when we substitute 1, we also substitute 1 there plus 3. 11 minus 3 is equals to 8. A, so 1 minus 1 will be 0, and 0 multiplied by a will be 0, so we'll be left with 1 plus 3 is equals to 4. So our b will be 8 divided by 4, which is equals to 2. From here, we substitute x as negative 3. Negative 3 minus 1. Negative 3 plus 3 will be equals to 0. So we'll be left with a multiplied by minus 4. 11 minus 3, this will be equals to 9 plus 3. So this will be 11 plus 9, and 11 plus 9 is equals to 20. So we'll have a equal, we divide both sides by negative 4. So we have a as 20 minus 4, which is equals to negative 5. So our integral will have a over x plus 3. Our a, we said that it's equals to -5 over x plus 3 plus b over x minus 1. Our b, we determine it as 2 over x minus 1 dx. Now we have to integrate. So -5 divided by x plus 3. So we don't have any square here, and we don't have x at our numerator. So this will be -5 ln of x plus 3 plus integrating 2 over x minus 1, we get 2 ln of x minus 1 plus c. Okay, this will be equals to integrating -5 over x plus 3, we get -5 ln of x plus 3. Integrating 2 over x minus 1, we get 2 of ln of x minus 1 plus c.